Hey Aman, you're doing the electromagnetics course, right?
Yes, yes.
Can you tell me any home appliances that use electromagnetic waves?
There are many such appliances like radios, televisions, even your cell phone through which you keep on chatting with your girlfriend. And of course, microwave ovens.
Oh right, microwave ovens. I always wondered how those things worked. Can you tell me something about them?
Of course, yes. Microwave ovens can be used from reheating leftovers to cooking food. A microwave contains three main components: a vacuum tube called magnetron that generates the energy that heats food, a waveguide hidden in the wall to direct the energy to the food, and this chamber to hold the food and safely contain microwave radiation.
But what's so special about microwaves? Why are they used for heating food?
Microwaves have that specific wavelength that can be easily absorbed by water, fats, and sugars, basically the main constituents of food.
Food.
Okay, consider a water molecule which is positively charged at one end and negatively charged at the other. They are exposed to electromagnetic waves which are directed by the waveguide. These EM waves contain electric and magnetic fields which keep on changing direction very rapidly. Water will try to align with this electric field. The changing field rocks the water molecule back and forth rapidly, and molecular friction from this creates heat, which eventually heats up the food.
But why did the microwave ovens replace the traditional ovens?
In traditional ovens, the walls radiated heat which cook outside of the food, but the inside was heated with conduction from the surface to inside. In contrast, microwaves penetrate into the food, which means whole mass of the food can be cooked simultaneously.
But I don't understand one thing. How exactly are microwaves generated in a microwave oven?
Microwaves are produced by using a device called magnetron. Did you know that the first magnetron was developed in the UK in 1940? It's made up of a copper tube and a copper rod running down the center and vacuum between the two. A high voltage is applied across the two conductors, which causes electrons to move through the vacuum from the rod to the tube. But they don't move in a straight line. The tube is also held in a magnetic field, and this applies force on the electrons, which makes them spiral outwards. As the electrons spin out like this, they pass small openings on the side of the tube. The electrons in the cavity behave similarly like air trapped in a bottle when you make a note while blowing across the top. In the bottle, the air vibrates in and out of the bottle opening, creating sound. Electrons spiraling across the cavity is a bit like you blowing across the bottle. They make the electrons in the cavity vibrate in and out, producing microwaves.
Well, that's all fascinating. But sometimes it happens that some portion of the food remains cold. Why is it so?
It's because we have standing waves inside the oven. We have three-dimensional standing waves, but let me explain you using 1D standing wave. As you can see, these nodes correspond to the cold spot, whereas these peaks correspond to the greatest energy of the wave. That is, you get maximum heating. So, there you have it, the source of your hot and sizzling food.